Hello, everyone. Welcome to yet another Linkafitty's deep dive into new AI tech. It's kind of wild how much we lean on these large language models now, right?
But have you ever noticed, like, even with all their smarts, they can be kind of slow and even expensive to actually use, especially when they're, like, really trying to think things through?
Yeah, totally. That's a really good point. It's especially noticeable with this thing called chain of thought prompting. It's like COUTI for short. You basically walk the model through a problem step by step, which works really well. But you get these massive outputs, and all that extra text like really adds up when it comes to processing time and the cost.
It's like they're overthinking a simple problem, like they write a whole essay when a short answer would do.
That's a great way to put it. And that's exactly what we're diving into today. We're looking at this brand new research paper. It's called Chain of Draft, Thinking Faster by Writing Less. The authors are Silei Lingxiao and Pengcheng. They're from Zoom Communications, and they came up with this really cool solution. It's called Chain of Draft, or CUD for short. And we've got excerpts from the paper itself. Chain of Draft 25502 860 V1 PF. So we're getting this right from the source.
Zoom communication that makes total sense. They live and breathe real-time communication. So they got to be all about efficiency. So how does this chain of draft thing actually work?
Okay, so think about how we solve problems as humans. Like, we often start with rough drafts, or we just jot down key ideas instead of writing out every single step, And that's kind of what COD does. It prompts LLMs to generate these really concise information outputs for each step, instead of those super long explanations that we see with CUD.
Okay, so it's like using bullet points instead of paragraphs.
Yeah, but how do we know that, like, sacrificing all that detail doesn't mess with the model's accuracy?
Well, that's where figure 1 from the paper comes in. This graph is really important because it visually compares standard prompting CODI and TOD, and it looks at how they do across all these different tasks. And what's really cool is that CODI's accuracy is right up there with CODI. Sometimes it's even better, and it uses way fewer tokens. Just a quick reminder, what are those again?
Oh, yeah. Think of tokens as like the basic building blocks of language, the stuff that LLMs process. More tokens means more processing power and more time. And in figure 1, you can see that COD consistently has these narrower bars. So that means fewer tokens used, but the height's about the same, which means the accuracy is comparable to COD. And this is true across like all these different tasks: arithmetic, common sense, and symbolic reasoning.
Okay, I'm starting to get why this is so cool. Can you give me an actual example of how FIOD works in practice?
Sure. The paper uses the simple lollipop problem to show the difference between cod and cod. Imagine you ask an LM, Jason had 20 lollipops. He gave Denny some lollipops. Now Jason has 12 lollipops. How many lollipops did Jason give to Denny?
Oh yeah, I remember those word problems from like way back.
Right? So with code, the model might give you a step-by-step breakdown. Like, Jason started with 20 lollipops. He now has 12. The difference is 8. Therefore, he gave Denny 8 lollipops, which is correct, but kind of long-winded, right?
Yeah, it's like it's trying to show off that it did the work.
Exactly. Now, with code, the answer might be something like 20x 20x be 8. Just the equation and the solution. No extra stuff.
Whoa, that's a big difference. So code is like getting straight to the point, while code takes the scenic route.
Exactly. And that difference in like how much they write translates to a big reduction in tokens, which, like we saw in figure 1, can save a ton of processing time and cost.
Okay, so we've seen the percent in figure 1 and with this lollipop example.
But how did the researchers actually test code, like, in a more rigorous way?
Great question. In section 4 of the paper, they describe their whole experiment setup. It's really interesting. They tested code against code and standard prompting across all these different reasoning tasks. They used popular LLMs like GP40 and Claude 3.5 Sonnet.
So, they really put TiOD through the ringer using all kinds of challenges and some of the most advanced LLMs out there. What specific tasks did they use?
Okay, so they focused on 3 main categories: arithmetic reasoning, common sense reasoning, and symbolic reasoning. For arithmetic reasoning, they used this challenging data set called GSM-AK. It's got thousands of grade school level math problems.
So, those word problems are actually a pretty good test of an LLM's reasoning skills. What about common sense reasoning?
For common sense reasoning, they used tasks from Big Bench. It's this massive benchmark for evaluating LMs. They specifically looked at date understanding and sports understanding, which require the model to actually grasp real-world concepts and relationships, and then for symbolic reasoning, they designed their own task based on coin flips. This task makes the LM track like the state of a coin after a bunch of flips, so it's testing its logical deduction skills.
So they covered a lot of ground with these tasks. What did they find? Did COD actually live up to the hype?
The results are honestly amazing across the board. COD consistently used way fewer tokens than COD. Sometimes it was using less than 10% of the tokens while getting the same or even better accuracy.
Wow, that's incredible. Can you give me some specific examples? Like, were there any tasks where COD really blew the others out of the water?
Let's start with arithmetic reasoning on the GSM-AK dataset. Both COD and CHOD did way better than standard prompting, which just shows you how powerful chain of thought techniques are for this type of reasoning. COD got really impressive accuracy, but it used a ton of tokens. CHOD got 90% accuracy while using 80% fewer tokens than COD. They even calculated the latency reductions, and for GTC4, OSI-OD was about 3.2 seconds faster on average.
It's not just about theoretical savings. It's about real-world speed improvements, too. How about the common sense reasoning tasks?
The common sense reasoning results were even more interesting because there were some really cool things we didn't expect. On the date understanding task, FEOD actually beat COTI in terms of accuracy. So, in some cases, being more concise might lead to better reasoning.
Hold on. So, being more concise actually improved the model's understanding. That's wild. What about the sports understanding task?
The sports understanding task is where things get crazy. With Claude 3.5, Sonic COD got a 92.4% reduction in token usage. That means it was using less than 8% of the tokens that COTI was using and still getting almost the same accuracy.
92.4%. That's insane. It's like going from writing a novel to just giving the key plot points in one sentence.
Okay, I got to know what about the symbolic reasoning task with the coin flips. Did TOD keep winning?
Even on the simple as COD's efficiency was obvious, both COTI and COD got perfect accuracy, but COD used way fewer tokens to get there. For GPT-4, it was a 68% reduction, and for Claude 3.5 Sonnet, a crazy 86% reduction.
So even when perfect accuracy is possible with both methods, COD still wins in terms of resource usage and speed.
Exactly. And this brings us to the bigger implications of COD. It's not just about faster math problems or coin flips. It's about real-world applications where speed is super important, like chat bots, voice assistants, or anything that needs to respond almost instantly.
Yeah, that makes sense. You don't want to be waiting 5 seconds for your voice assistant to tell you the weather.
Right? But it's not just about speed. It's about cost and accessibility, too. COD's efficiency could be a total gamacher for applications that don't have a lot of computational resources. Imagine running powerful AI right on your phone without killing your battery or needing a supercompute. That's the kind of potential we're talking about.
This is really exciting. So, we're talking about a future where LMs are not just smart, but also super fast, efficient, and accessible. I'm in. But before we go too far, I want to hear more about the technical details, like, how does COD actually pull this off?
Sure. In the next part, we'll dig deeper into the paper's analysis of why COD works so well. We'll look at things like overthinking in LLMs and the potential impact of FOD on how we design and train these models in the future.
This idea that TOD might actually make reasoning better in some cases is really interesting to me. It seems kind of weird that being more concise could actually improve accuracy.
Yeah, it's pretty fascinating, right? And the authors actually dive into this in section 3 of the paper. They try to figure out why CUD works so well. They think that regular cut prompting can sometimes lead to what they call overthinking even though it works well. It's like, imagine a student who's trying to show off how much they know. So, they write this super long and complicated answer when a simple one would then just fine.
Oh, so it's like the LM is trying to prove the problem by writing a ton of text even if all that extra detail isn't really necessary.
Exactly. And this whole overthinking thing, it might show that the model knows a lot, but it can actually make it less efficient. And it can even cause errors. It's kind of like a computer program with a bunch of extra code that it doesn't need. It might still give you the right answer, but it's going to take way longer and use more resources than a program that's more streamlined.
So, KDE is like a code optimizer for LMs. It strips away all the unnecessary stuff to get to the core of the reasoning.
That's a great way to think about it. And this idea of overthinking in LLMs is actually a really hot topic in research right now. People are starting to realize that just making models bigger and giving them more data isn't always the answer. We got to find ways to make them more efficient, more strategic in how they think. And TODR seems like a really promising step in that direction.
It's almost like we're learning from how our own brains work. Sometimes less is more when you're trying to think effectively.
Totally. And that brings us to another really cool thing about COD. It could actually change how we design and train LLM in the future. Right now, like they talk about in section 5, most LLMs are trained to generate text that sounds like a human wrote it, so they end up being wordy and complex. But what if we change that? What if we train them to be more concise and efficient in how they reason, like what we see with Cody?
That's a really cool idea. It's like we're going beyond just copying human language. We're trying to copy how efficiently humans actually think.
Exactly. And if we can train LLMs with that goal in mind, it could totally change the field. We might end up with models that are not just faster and cheaper, but they're also more transparent, easier to understand. So we can actually see how they're getting their answers.
That would be huge. But before we get too lost in the future, let's come back to the experiments for a minute. In part 1, we talked about how CUD used way fewer tokens, and it was faster too. Can you walk me through some of the most impressive results?
Of course. Let's go back to those 3 categories of reasoning tasks: arithmetic reasoning, common sense reasoning, and symbolic reasoning. Start with arithmetic reasoning on that GSMAK data set. Remember, that's the one with the tough grade school math problems. Both COT and COD were way better than just standard prompting, which just shows you the power of chain of thought techniques in general. CUD got awesome accuracy, but it used a lot of tokens. CUD, though, got 91% accuracy while using 82% fewer tokens than CUD.
So, it's a massive efficiency boost without losing accuracy. But you were saying things got even more interesting with the common sense reasoning tasks.
Yeah, the common sense reasoning tasks were really cool because they showed us some stuff we weren't expecting. So those were the tasks with understanding dates and sports concepts on the date understanding task, called actually beat Katu, when it came to accuracy, especially with the Claude 3.5 Sonnet model. So it seems like sometimes at least being concise can actually lead to better reasoning, maybe because it forces the model to focus on the most important info.
That's so interesting. It kind of goes against the idea that more detail always means better understanding.
I know, right? And then there's the sports understanding task. This is where TOD's efficiency was just off the charts. With Claude 3.5, Sonic Code had a 92.4% reduction in token usage compared to COD. That's nuts. It's like the model was able to boil down everything about sports into just a few key points.
92.4%? That's crazy. You got to tell me about the symbolic reasoning task too. The one with the coin flips. Did TOD keep up its winning streak there?
Even on that one, which seemed pretty simple, COD was still way more efficient. KD and FOD both got 100% accuracy, but COD used way fewer tokens to get there. With GPT-40, it was a 60% reduction compared to COD-T, and with Claude 3.5 Sonnet, a whopping 86% reduction.
So even when both methods get the answer right, COD is still better when it comes to efficiency.
Exactly. And when you put all these results together with that analysis of overthinking and how this could change LLM training, it paints a really exciting picture of what COD could do.
It's making me rethink how I use LM. I'm starting to see conciseness as more than just a way to save time and resources. It might actually be a way to make them reason better.
I think that's a huge takeaway. It shows that this research is about more than just a technical tweak. It's about changing how we think about how aliens reason, and it could lead to totally new ways of designing and training these models.
This has been awesome, but I'm curious about the nuts and bolts of it all. How does COD actually work on a technical level? What's going on under the hood that makes it so efficient?
That's a great question, and the researchers get into all the details in Section 4. They explain exactly how prompting works and the specific techniques they use to get these amazing results.
Okay, let's get technical then.
All right, let's do it. First, let's quickly recap how regular code prompting works. Basically, you give the LLM a series of steps to follow. You're guiding it to the final answer. This helps it break down tough problems into smaller chunks, and it often leads to better accuracy.
Yeah, we talked about that earlier with the lollipop problem. Kot walked through the problem step by step. It explained the logic behind each step.
Right now, the big difference with code is that it wants the LLM to express those steps in a way shorter way. Instead of writing out full sentences or paragraphs, code tells the model to make each step super concise.
So, it's kind of like using shorthand or abbreviations instead of writing everything out longhand.
Yeah, that's a great analogy. And the researchers used a few tricks to make the responses so concise. One was limiting how many words the model could use for each step. In their experiments, they found that a limit of 5 words per step worked really well. Whoa. So, they're literally forcing the model to think in sound bites.
You could say that. This forces it to get rid of all the fluff and focus on just the most important stuff.
That makes sense. I can see how that would lead to way fewer tokens. Did they use any other techniques to make the responses shorter?
They also used some clever prompt engineering to encourage concise answers. Like they used prompts that specifically told the model, think step by step, but only use a few words. Use a few words for each step.
So they're not just limiting the length of the output. They're also telling the model to be concise from the very beginning. It's like they're teaching the LLM to think less is more.
Exactly. And when you combine these output length limits with these targeted prompts, you get a really powerful way to boost efficiency without hurting accuracy.
This is all so cool. But did they run into any problems when they were doing this? Were there any situations where COD didn't work as well as they hoped?
That's a great question. And they talk about the limitations of COD in Section 6 of the paper. They're talking about some potential downsides.
Okay, I'm all ears. What did they find?
One thing they point out is that how well code works might depend on the task. For some tasks that need you to really understand all the nuances and context, being super concise might not cut it. You might not be able to capture all the necessary info.
That makes sense. It's like trying to explain some complex scientific theory in a single tweet. You might be able to get the basic idea across, but you're going to lose a lot of the details.
Right, and the researchers say for tasks like that, Cody might still be the better option, even if it uses more tokens and takes longer.
So, it's not a magic bullet. There are still times when code is better.
Totally. And another challenge is figuring out just how concise to be. It's different for every task and every model. If you go too far, you might lose info or accuracy. But if you're not concise enough, you might not get the efficiency gains of code.
It's like finding the sweet spot. Not too vague, not too wordy.
Exactly. And that's something that needs more research. We need better ways to figure out the optimal level of conciseness for different situations.
This has been super insightful, but I'm also thinking about the bigger picture. How could FOD change the future of AI and how it fits into society? If we can make these powerful tools a lot faster, cheaper, and more efficient today, what could that mean for how we use them and how they affect our lives?
That's a huge question, and it's worth digging into a lot more. So in our last part, let's switch gears a bit. Let's go from the technical stuff to the broader societal implications of COD. We'll think about both the good stuff and the challenges that come with it.
It's kind of mind-blowing that something as simple as being concise could have such a huge impact on the world of LLMs.
Yeah, it really is, and the potential of COD goes way beyond just technical stuff. Like we talked about before, COD could make these powerful AI tools available to pretty much anyone, individuals, organizations, you name it.
That would be incredible. Imagine if startups, researchers, teachers, even artists could use LLMs without needing a ton of computing power.
Exactly. It could lead to like a burst of creativity and innovation. People from all walks of life could find new and awesome ways to use these tools.
It's like AI becoming as common as electricity or the internet. It could give people the power to do things that we can't even imagine right now.
I love that analogy, and it's not just about access. Kadi's focus on efficiency could also be a big win for the environment. Training and running those big LLMs takes a massive amount of energy, which contributes to climate change and all those other environmental problems.
So, COD could help us make AI more sustainable. We can reduce its impact on the planet while still taking advantage of all its potential.
Exactly, and there are other benefits for society too. For example, COD could revolutionize things like healthcare, education, and customer service because it can make LLM so much faster and more responsive.
Imagine having AI tutors that can give you personalized lessons in real time, or AI medical assistants that can analyze your symptoms and give you a diagnosis super fast. Those are just a couple of examples. FOD could make our lives better in tons of ways. Make us smarter, healthier, and more productive.
It's like AI become this invisible force that's always there, helping us solve problems and making our lives easier.
That's a great way to put it. But of course, with any powerful technology, we have to think about the risks too. We need to make sure these tools are used ethically and responsibly, especially as they become more efficient and easier to get.
That's super important. We have to be careful about things like bias, fairness, and accountability. We don't want these tools to be misused or make existing problems worse.
You got it. And actually, the ideas behind COD, with its focus on transparency and making things easy to understand, could help with this. By pushing LLMs to be more concise, we might be able to understand their reasoning better, which is crucial for building trust and making sure they're used responsibly.
So COD isn't just a cool new technique, It's a chance to rethink how we develop and use AI in a more thoughtful and ethical way.
I think that's a really key point. It's a reminder that we're not just trying to create powerful AI. We also need to make sure it benefits everyone.
This has been an awesome deep dive. We've covered so much ground, from the nitty-gritty details of FOD to how it could change entire industries and even society as a whole. It's amazing to think that being concise could be the key to a more efficient, accessible, and ethical future for AI.
I totally agree. It just goes to show you how powerful innovative thinking can be. We need to keep pushing the boundaries and see what other amazing ideas are out there.
That's what makes this field so exciting. It's constantly evolving with new discoveries happening all the time. It's a great time to be following AI, and I can't wait to see what's next.
Me too. And as we wrap up this deep dive into Chain of Draft, let's remember that we all have a say in what the future of AI looks like. It's up to us to make sure it's a force for good, one that helps humanity achieve incredible things. So, keep exploring, keep learning, and join us on this amazing journey as we explore the world of AI. Until next time, Linkvideo's fans, keep diving deep. And please remember to like and subscribe to our channel, so we could bring to you more deep AI dives. Thank you.